This will be your first lesson in trig identities. Naturally, we can't start without our joke. What did the vinaigrette say to the refrigerator? Close the door, I'm dressing. And now on to the real work. What are trigonometric identities? Trig identities are qualities that involve trigonometric functions and are true for every value of the occurring variables where both sides of the equality are defined. And they are useful whenever expressions involving trig functions need to be simplified. The learning goal today is to prove some simple trigonometric identities. Let's begin by defining a few that we've not seen before. We've seen sin x, cos x, and tan x. Cosecant x is equivalent to 1 over sin x. Secant x is equivalent to 1 over cos x. Tan x, surprisingly, can be written as sin x over cos x. And cotan x then would be the flip of tan x, so cos x over sin x. So you can see that we've changed everything here into sin x, so 1 over sin x, 1 over cos x, so sin x and cos x. So all of these things, cosecant, secant, tan, and cotan, can all be written in terms of sine and cos. So our goal today is going to be changing things so they have just sine and cos, and then simplifying if we can. Another identity is called the Pythagorean identity, and it is because sine squared x plus cos squared x equals 1. So anytime we see sine squared x and a cos squared x added together, we can replace it with a 1. The left side here is always equivalent to the right side 1, and x can be any value. So as long as the x here, if it's 130 and the x is 130 here, then sine squared 130 plus cos squared 130 is equal to 1. Try it with any number. This problem says simplify sin x cotan x minus sin x cos x. My first step is to make sure that everything is in sine and cosine. I replaced cotan x with cosine x over sine x. Everything else is the same, so this sine x is here and the sine x cos x is here. See that there's a sine x here, and on the bottom of this fraction is another sine x. Those cancel, and I'm left with just cos x. So my new expression is cos x minus sine x cos x. I notice here that there's a common factor of cos x in both terms, in this term and in this term, so I'm going to factor that out. Okay, so now that I factored it out, I divided cos x by cos x and got 1. I divided sin x cos x by cos x and got minus sin x. And now I have simplified this expression sin x cotan x minus sin x cosine x, and it is equivalent to cos x times 1 minus sin x. This is also a simplified question. I have cos x times 1 plus secant x times cos x minus 1. So I've got cos x here and cos x here, but this sec x, I'm going to replace it with a 1 over cos x and see what happens. I replace the secant x with 1 over cos x, and I can use my Trig toolkit to remind me of what these identities are. So there's certain things you're going to be given on the test and on the exam. So you'll be given that sec x is equal to 1 over cos x. So I'm going to expand these and see what may or may not happen. So I used the distributive property, and I did cos x times 1 is cos x, and cos x times 1 over cos x leaves me with just 1. Now this is cos x plus 1 and cos x minus 1. Maybe you recognize that. That would be the factored form of a difference of squares. So really I can rewrite this as a difference of squares. So now I have it as a difference of squares, the first term squared, cos x, minus the second term squared, minus 1. Okay, so we know that sine squared x plus cos squared x is equal to 1. That's the Pythagorean identity. So if I were to rearrange that, leave the cos squared on this side and bring the 1 over, becomes a minus 1, and then take this sine squared x to the other side, becomes a minus sine squared x. So this particular form ends up being simply minus sine squared x. I think this is really cool that we are able to start with something that looks kind of complicated and simplify it into something rather simple. It's awesome. For the past few pages, the term at the top said simplify. This one actually says prove. So I'm going to set up proofs a little bit differently. I need to keep the left side on one side and the right side on the other, and then work each of them until they get exactly the same thing. So I'll show you what I mean. Okay, so I've set it up so that I have my tan x cos x on the left side and my sin x on the right. So the reality is, if it says prove, it's not true until we prove that it's true. So I'm going to keep my sides separate until they both say the same thing. So this one's about as simple as it's going to get. It's sin x. So what I need to do is work with this one using our identities to try and make it simpler. I know that tan x is really sin x over cos x. So this tan x is equivalent to sin x over cos x. So now I have sin x over cos x times cos x. Well, clearly we can cancel this cos x on the top with this cos x on the bottom, and I am left with just sin x. At this point, I notice that my left side equals my right side. Therefore, I have proved that this particular identity is true. So then I would say left side equals right side, and so therefore it's true. The identity is true. One more question. Again, this is a proof. It doesn't say so. Let me write that. I'm going to prove that this left side equals this right side. So I'm going to write up my left side and my right side. My left side is tan x plus 1 over tan x. My right side is 1 over sin x cos x. So now, in the past, I told you the best idea is to replace everything you can with sines and coses. So if you look at the right side, we already have just sin x and cos x. So I'm going to leave this side alone, and I'm going to work with this one to make it look like this, I hope. We know that tan x is equal to sin x over cos x. That's on our Trig Identities toolkit sheet. So I'm going to replace this with a sin x over cos x, and I'm going to replace this with a sin x over cos x and see what happens. Okay, so this looks nice, but this is looking pretty messy. And 1 over sin x over cos x is really just 1 divided by this, which means that this one will flip if you actually try that out. So I end up with sin x over cos x, and this becomes cos x over sin x. So you can try it on your own, but try 1 divided by sin x over cos x, and you'll get this, cos x over sin x. For the left side, I still don't look like the right side, so I'm going to find a common denominator between this cos x and this sin x. So I'm multiplying this one by sin x and this one by cos x. Let's see what happens. Now remember, when you're finding a common denominator, I used the common denominator of cos x sin x. So I needed to multiply this denominator by sin x, which means I need to multiply the numerator by sin x as well. And similarly over here with the cos x. You'll notice when I do that, the sin x times the sin x gives sin squared x, the cos x times the cos x gives cos squared x, and of course we have our common denominator. But our Pythagorean identity says this sin squared x plus cos squared x is actually equal to 1. So we can write this, the numerator, as just a 1 over cos x sin x. And if I compare this fraction with this one, they look the same. I know the sine and cos are backwards, but it doesn't matter. Sin x times cos x is the same as cos x times sin x. So these are true now. So my left side equals my right side, and the identity is true. Good luck trying your own.